A lovely good afternoon to you, grade 12. Welcome to today's mathematical literacy lesson. My name is Mampani Kekana. The lesson is brought to you by the Gauteng Department of Education in collaboration with Cyborg Discovery Center. Okay, boys and girls, I understand that today you were writing your mathematical literacy paper 1, and in our hope you guys did well in that paper. So it is now time to prepare for paper 2 on Monday. So you guys have got no excuse not to do better in paper 2 than in paper 1, because you've got all the time to you. You've got all the time to prepare yourself. You've got today, you've got Saturday, you've got Sunday. So I'm quite sure that after today's presentation, where we are going to guide you on how to prepare for paper 2 on Monday. So please stay tuned up until the end of the session. So, boys and girls, at this stage, you should be in a position, okay? You should be in a position where you can answer any question in MathsLit. Remember, your educators have done their part. I think they have done a great job throughout the year. They have covered the syllabus. So it is now up to you. Make sure that you prepare yourself. It is now up to you to make sure that you prepare yourself for the papers that are coming. Very, very important. It's very important that you need to know what you are going to study for paper 2 on Monday. So make sure that you study the correct topics for Monday. Now, what is expected of you for Monday's paper? In today's lesson, the objective of today's lesson, boys and girls, is just to provide the scope of the content that is going to be assessed in Mathematical Literacy Preliminary Examination Paper 2. And then again, to highlight the format of the exam structure that is in Paper 2, to highlight the order of questions in Paper 2, and then to provide possible exam type questions. So it means we're going to go through the exam structure, and then after that, if time allows us, then we're going to look at the typical questions that will come in paper 2. Now, like I said, it's very important that you know which topics you're going to study for Monday. Paper 2, the topics are maps, plans, and other representations. Okay, in simple terms, in MathsLit, we just say maps and plans. So you need to know that for paper 2, you need to go and prepare or study maps and plans. And then according to the examination guideline, maps and plans will count about 40%. Now 40%, if we convert it to marks, 40% of 150 marks, it's 60 marks. And then we also have measurements. Then for measurement, it's about 55%. If we convert the 55%, it's 83 marks. So for paper 2, 83 marks will come from measurement. And then again, this one, likely boys and girls, you have already studied probability. You have already studied probability for paper 1. So you can just go and revise probability again. If maybe you felt like the questions that you answered, that are the questions that were based on probability today, you could not answer them well. So it's time for you to go and do some revision, because probability will be in paper 2 again. But in paper 2, it's going to be about 5%. Okay, then in terms of marks, it's just 7 marks. Right. Now, the structure of paper 2, boys and girls. Paper 2 may have 4 to 5 questions. Like you've seen in paper 1, you had about 4 to 5 questions. So that is going to be the same thing in paper 2 as well. Paper 2, it's going to have about 4 to 5. It might have 4 questions. It might have 5 questions, but the minimum is 4. Right. Now, if we look at the structure of paper 2, this is what you must expect. In question 1, you are going to get a question a question with 30 marks. 30 marks, we say plus or minus, so it might be 25, it might be 35. So 30 marks. we say question 1 is level 1 mixed questions. Remember, you're going to write about 2 main topics, that is measurement and maps and plans. Now, when we talk about level 1 questions, boys and girls, these are the questions that you need to get them right. You cannot afford to lose marks on question 1 because this would be the easiest questions that you will get in the question paper. That means the easiest questions will actually come from question 1. So please make sure that you go and try to answer all the questions in question 1 correctly. Make sure that you answer them correctly. You cannot afford to lose any mark in this question. So those questions will come from measurement and maps and plans. It's 30 marks, so it's about 30 marks. Please just ensure that you get at least 25 marks. If you don't get total, at least 25, because this will be the easiest questions in the whole paper. And then in question 2, you must expect questions that are based on maps and plans. Questions that are based on maps and plans. Question 3, it's measurement. So it means you must go and when you study, you check. Question 2 is maps and plans. What are the sections of maps and plans? The same thing with question 3. What are the sections of measurement? So that you prepare yourself for that paper on Monday. Right, then we're also going to have question 4. Question 4, it says integrated context on measurement and maps and plans. Integrated context. Now, what do we mean by integrated? Integrated simply means you're going to have a combination. In other words, a question will be based on both measurement and maps and plans. It's a combination of both topics. Then, again, if you look at the main topics in paper 2, we said it's maps and plans and it's measurement. But we didn't say anything about finance, right? Remember, you wrote about finance in today's paper. But just remember that there's going to be a little bit of finance. Likely, you have studied finance for paper 1. So obviously, maybe you just need to go and refresh your memory when we come to finance. You're going to get a little bit of finance in paper 2 as well, but it's not going to be a lot of marks. That finance will be related to measurement and maps and plans. So if you struggled with finance today, so it means you must also go and revise it, because there's going to be some questions about finance. Boys and girls, remember, you cannot take this for granted. Every mark counts. Every mark is very, very important. That is why I usually say to the learners, what you don't know now, okay, you know that you are going to write paper 2, but there are certain topics that you are not sure about. Just know that if you are not sure about them, it means you are already losing marks. So just make sure that you go and practice those questions. Right, and then we are going to have question 5. Now, question 5, it's also going to be about combination of questions that will come from measurement, maps and plans. So it means if you go to question 2, it's going to be about maps and plans only. Question 3, measurement only. But question 4 and 5, you're going to get a combination of questions from both topics. Right, then again, question 5, there we've got probability. But probability can be in any of the questions. It can be asked in question 1, it can be asked in question 2, it can be asked in question 3, question 4, and question 5. So it's not going to be a question on its own. Right. Then the other thing that is very, very important, boys and girls, in most cases, you would not be able to do calculations if you don't know the definitions. So for you to do the calculations, you should know what you're calculating. If I say calculate or determine a radius, obviously you must know what the radius is. In most cases, you would not be able to determine a radius if you don't know how to define a radius. So like in paper 1, we also have terminologies that you need to remember when you go and write paper 2. Now, some of the terminologies in paper 2 that you might encounter, or some of the terms that you might encounter in paper 2 are the following. The first one is conversion. What do we mean when we say conversion? Okay, if they say convert, okay, conversion. So when we talk about conversion, we're talking about changing one unit to the other unit using a conversion factor. So in other words, you are changing one unit to another unit. For instance, if you have to convert a centimeter to a meter, it means you are actually changing a unit to another unit using a conversion factor. Now, the next one is conversion factor. What do we mean by conversion factor? A conversion factor is what you must use to convert. Like for instance, if I say convert a centimeter to meters, okay, centimeter to meters, what are you going to use to convert? Centimeter to meters. Then you must think about the conversion factor. How do we convert from centimeter to meter? Okay, between a centimeter and a meter, there's 100. So from centimeter to a meter, are you going to multiply by 100 or are you going to divide? So in this case, you're going to divide by 100. So it means the 100 is the conversion factor. It's the value that must be used to convert between centimeter and meter. We also have degree Celsius. We know that degree Celsius is a unit that is used to measure a temperature, or it's actually a unit of a temperature. Then we've got analog. Okay, now when we talk about analog, remember if you've got a watch or if you've got a clock, okay, that clock has got hands, okay, so it means for this one, the analog, it means we are using hands to point at the value. Okay, like a watch will indicate, or for instance, a clock will indicate how many minutes, how many hours. So in that case, we say that is in the form of an analog. Or for instance, if you take a bathroom scale, some of the traditional bathroom scale are still using the hands. So you will see a hand moving there. So it means that is a type of an analog. Then we've got digital. So digital it indicates information or measurement in the form of numbers. It indicates in the form of numbers. Like for instance, we've got bathroom scale that indicates the numbers instead of a hand moving, indicating the value of the weight. So for the digital, or you have a watch that indicates time in the form of numbers. So that will be digital. Then we've got again a distance. Okay. Now with the distance, it's the length of space between 2 points. The length of space between 2 points. Usually when we come to definition, boys and girls, the first thing that comes into your mind when you see the weight, please just write it down in detail, as long as your definition will be relevant. We do not actually expect you to give a definition word for word exactly as is. So let us try to define all these terminologies using our own words. And then we've got length. Now with length is measurement of something. If we have to measure something from one end to the other end, then that will be a length. And then elapsed time. Okay, elapsed time. Let's say, for instance, you are walking from home to school. If you leave home at 7:15, then you arrive at school at 7:45. So what is the elapsed time? How much time did you spend there? Okay, from 7:15 to 7:45, that will be about 30 minutes. Okay, so that will be the elapsed time, the amount of time spent or the duration. Then we've got imperial system. Now, imperial system is about units of measurement. We know these are the international units like inches, miles. Okay, we've got inches, we've got miles, we've got pounds, and so on and so on. All those measurements that are not used in South Africa, we call them imperial system. And then we've got again metric system. These ones are very easy. The one that we're using locally, centimeters, kilometers, grams, kilograms, and so on. Okay, and then we've got the weight measure. Now, if you have to measure, it means you have to give a size. If you have to measure, it means you have to give a size by using an instrument. If I have to measure a weight, it means I have to use a bathroom scale. If I have to measure the length of a classroom, then I'll have to use a measuring tape. So measure, it simply means use an instrument to give a size. Then we've got again measuring. Obviously, measuring comes from the word measure. Then we've got mass or weight. Then mass or weight, it's an amount of matter in an object. An amount of matter in an object. Right. Then we've got these two words of which most of you are struggling to differentiate. So also, you must also be able to differentiate the two. What is the difference between volume and capacity? The difference between volume and capacity, I usually give an example that if I've got a bottle, okay, this bottle has occupied an amount of space in the studio, okay? This bottle has occupied a certain space in the studio, so it means that will be a volume. But the amount of space inside the bottle, that will be a capacity. Okay, so just think about it from that point, that if you've got an object like this one, the amount of space that is occupied by this, that will be a volume, but the amount of space inside its capacity. Then, boys and girls, we've got again, when we go to maps and plans, scale factor, okay? Scale factor. Now, when we come to scale factor, it's by how much an object has been increased or decreased, or by how much an object has been enlarged or reduced. So there we're having a scale factor. Like for instance, if I've got 1 is to 100, so 1 is to 100, it simply means the object has been reduced by 100. In other words, it's 100 times smaller than what it is in reality. Okay? But if you've got other way around, let's say we've got 5 is to 1, this one is other way around, it means the object that is indicated there is enlarged. Those who are doing life sciences, they will know that if they're talking about cells, in order for them to see the cells, they need to enlarge them. But in reality, they are not that large, okay? They are not that big. So if the scale is indicated in this form, it means that object has been enlarged. But if it's other way around, if we start with 1, it means it has been reduced. Okay, then we've got again time. So you must also know about time. We also have radius. Okay, remember radius is it's half of a diameter. If you've got a circle, so if you've got a circle there, the length from the center to the boundary of a circle, that will be a radius. We also have a diameter, but a diameter, it's a line that divides a circle into two equal parts, a line that is passing through the center of a circle. So in this case, it is from this point passing through the center, and then that will be a diameter. Then perimeter. Okay, what do you understand by the word perimeter? Because the examiner might also ask you to define the word perimeter. Now, in terms of a perimeter, we know that it's the total length around a shape, okay? A total length around a two-dimensional shape. That will be a perimeter. We also have circumference, okay? Now, circumference is actually the same as perimeter, but it's just that we use the word circumference when we talk about a circle. Okay, when we come to a circle, we don't use the word perimeter. We use a special name, circumference, for a circle, but it is still the same as the total length around a circle. So circumference simply means total length around a circle, while perimeter is the total length around a two-dimensional figure. Then we've got an area. Area, if you have to calculate an area, now we've got a perimeter. Okay, now if you've got the perimeter, the amount of space within the perimeter, if, for instance, there's a rectangle, and then we said around, that is a perimeter. But the amount of space within the perimeter, that will be an area. Okay, the amount of space inside the boundary of a two-dimensional figure, that will be the area. Then we've got total surface area. Now, for total surface area is when we talk about a three-dimensional figure, Like, for instance, think about a box. A closed box. A closed box has got about 6 faces. Now, if you think about the area of each and every face, if you've got a box that is closed, it has got 6 faces. So it means if we take the area of each and every face, then we add them together. If we take the areas of all the faces, we add them together, we get what is called a total surface area. Then this one I've already explained, the volume. Okay, then we've got a number scale. So remember number scale when we come to maps and plans, so we must also go and check the number scale. Again, bar scale, you must also know the difference between number scale and bar scale. Then this one is, in most cases, the examiner will ask for a general direction. And then what we experienced in the past is most of the learners, when they say give a general direction, and then they start explaining direction, okay? They start explaining how to get to a point or to a destination. But in this case, when they ask for a general direction, they are actually asking for a compass direction. They want to know whether it's north, whether it's east, whether it's west, whether it's southeast, and so on and so on. So when you come to that one, when they say general direction, you don't explain, but you just give a compass direction. And then when we come to maps, you must know about the national road. National road, we know that in South Africa, national roads are indicated with the symbol N. Letter N indicates that that is a national road. You've got N1, you've got N2, you've got N14, and so on and so on. Then we also have regional roads. You might have seen the regional road. They will start with a letter R, capital letter R. You've got R101, you've got R80, okay, you've got R79, and so on and so on. So those are the regional roads. And then again, floor plan. So you must also go and prepare about the floor plan, and you must know the definition of a floor plan. Now, a floor plan, remember, it's actually when you want to see a plan. So a floor plan, it's when you see a plan of the house from above. Okay, so imagine your house, inside your house, but now you want to see it above. Think about the situation where you remove the roof. What are you going to see from above? So that will be the floor plan. And then if you've got an elevation, these are the side views. If you move around your house, okay, for each and every side, what are you going to see? So that will be an elevation. So now, boys and girls, terminologies are also very important, but you don't need to go and memorize them, as long as you can have an idea and be able to explain each and every definition. But you are not going to spend most of your time trying to memorize the terminologies. Okay, now, the most important thing, the most basic and important thing in Maths Lit, especially in paper 2, is conversion. Boys and girls, you must know how to convert. Okay, there's no way that you would not get a question where they're going to ask you to convert, right? So this is where you must start. Convert between metric system. So you must know how to convert from a kilometer to a meter. So we know that from a kilometer to a meter, you should know that you multiply by 1,000, right? And then if you convert from a meter to a centimeter, you multiply by 100. This is something that you must know now. And then from a centimeter to a millimeter, you multiply by 10. So you must know all these conversion factors. Kilometer to meter, you multiply by 1,000. From meter to centimeter, you multiply by 100. From centimeter to millimeter, you multiply by 100. You multiply by 10. Okay, so but what about the other way around? If you have to convert from a millimeter to a centimeter, you're going to divide. If you convert from a centimeter to a meter, you divide by 100. And then if you convert from meter to kilometer, you divide by 1,000. So you must also go and practice those conversions. The same thing when we convert mass or we convert mass, yes. Then we convert from kilogram to grams. You must remember that if you convert from kilograms to grams, we multiply by 1,000. And then from grams to milligrams, we multiply by 1,000. So this one we multiply by 1,000. Other way around is division. So you must also go and practice that. Then when we come to volume or capacity, we've got kiloliters, we've got liters, we've got milliliters. These are the 3 units that you must be able to convert between them. If you convert from kiloliter to liter, we multiply by 1000. Okay, and then if you convert from liter to milliliter, you multiply by 1000. So then if you want to convert from milliliter to liters, we divide by 1000. If you want to convert from liters to kiloliters, we divide by 1000. So you must just remember that. Okay, so for this one, we say from kiloliters to liters, you multiply by 1000. So that means if you've got 2 kiloliters and then you want to convert it to liters, you're going to multiply by 1000. Okay, then if you want to convert from liters to milliliters, you also multiply by 1000. So now these are some of the basics that you must also go and practice for Monday. Now, this is the most common table that most of you guys are using when we come to conversion. Even if it means you have to memorize this table so that it can help you. But if you've got the easier method that you have learned from your educators at school level, please, this is not the time. This is not the time to change the method. This is not the time to change any method that you have learned from your educators. If you are using a certain method and then that method is giving you correct answers, please make sure that you stick to that method. Otherwise, you're going to confuse yourself. I've just indicated this because I've seen that most of educators and learners are actually using this method just to memorize. Okay, so this one is King Henry died by drinking chocolate milk. Then they use this table to do the conversion. Right. Okay, then the other thing that is important, boys and girls, when we come to conversion is temperature. Okay, now temperature is what is important. You just need to know how to do the substitution there. And then please, boys and girls, don't take these things for granted. Make sure that you go and practice them. When you practice them, it means do the substitution, use your calculator and make sure that it gives you the correct answer. Okay, so that if it doesn't give you the correct answer, then you can be able to practice and practice and practice until you get to the correct answer. Then again, when we come to conversion time, it's also very important that you must remember the following. Okay, you must remember the following, or you should know the following, that in a minute, 1 minute is equals to 60 seconds. And we've got 1 hour is equals to 60 minutes. We've got a day, a normal day has got 24 hours. So these are some of the important notes that you must know. A day has got 24 hours. If the examiner has to ask you to convert 2 days to hours, he might not even tell you that one day is equals to 24 hours. It's something that you need to know. A normal week has got 7 days. And a month, we generally say it has got 4 weeks. Okay, but if it's got 4 weeks, and then you say 4 multiplied by 7, you actually get 28. But we know that some months actually have got more than 28 days. So for this one, we can say, but it can also be 28, 29, 30, or 31 days. Then again, we've got a year has 12 months, or 52 weeks, or 365 days. So if you have to convert a year to days, we just multiply by 365 days. We know that we've got 366 days, but if the examiner has to ask that question, and then he will have to specify if you have to use the leap year or not. Okay, but for now, we just take a normal year to have 365 days. Like they've indicated there, we don't normally consider a leap year. Okay, but if it has to be used, the examiner will specify. A decade, if we're talking about a decade, we're talking about a period of 10 years. And then a century, we're talking about a period of 100 years. Boys and girls, this will not be given. Okay, maybe by lucky, some of them might be given, but it's very important for you to know all of them. Right, then we have also spoken about the elapsed time, duration, and then I gave a very simple example that if you walk from school, if you walk from home and you leave at 7:15, you arrive at school at 7:45, the elapsed time there will be 30 minutes. It means you have actually spent 30 minutes. You would have spent 30 minutes on the road. Now, if you look at what is indicated here, it's the start time is 5:45 p.m. and then we've got end time is 11:15 p.m. Okay, 5:45 p.m., 11:15 p.m. Now we need to calculate the difference. Elapsed time according to this, it must be 5 hours, 30 minutes. But how do we get that? If we've got 5:45, and then we've got 11:15. So this one is 11:15. So you always take the end time and you subtract the start time. You always take the end time, you subtract the start time. So I've seen most of the learners, or some of the learners can actually do this by using a calculator, but it needs some practice, boys and girls. So if you don't know how to do it on a calculator, you can still do it manually. Like this one, if we have to say 11:15 minus 5:45, we can say 15 minus 45, but we know that we can't subtract 45 from 15. Then we take 1 hour there. So we're going to be left with 10. And then this one, when we bring that 1 hour, is going to be 60. Then we get 60 plus 15. Then we get 75. Then 75 minus 45, we get 30. And then we've got 10 minus 5. Then from 10 minus 5, we've got 5. So this will give us 5 hours, 30 minutes. That is how they get 5 hours. So it means from 5:45 to 11:15, 5:45 p.m. to 11:15 p.m., that is about 5 hours and 30 minutes. You must also be able to calculate the elapsed time as well. Then this one is also very important, boys and girls. In paper 2, when you get to maps and plans, they might ask you to measure a distance between 2 points. So what I've seen some learners who could not interpret what is indicated on their calculators. Now, boys and girls, it's very, very important that you indicate those very small lines, okay? Those small lines on your ruler, okay? The small lines on your ruler, like for instance, I only took part of a ruler here. It starts from 0. Remember, some rulers have got space there. So when you do the measurement, please make sure that you start measuring from 0. Just ignore the small space there. So you start measuring from 0, and then that is maybe up to 1. But what does it mean if you measure something, then it's only there? It only ends there. What does it mean? How do you interpret that? Then we need to check, what does each line represent? What does each line represent in this case, especially the green ones? We've got the green ones. What does each green line represent? We've got from 0 to 1. If you say 1 minus 0, you get 1. And then you divide by the number of intervals. How many intervals spaces are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you say 1 divided by 10. If you say 1 divided by 10, it's going to give you about 0,1. Okay, now if it's 0,1, it means each line is 0,1. Then how do you count? It means from 0, this is 0,1, this is 0,2, 0,3, 0,4, 0,5, 0,6, 0,7, 0,8, 0,9, and then that will be 1. After 0,1, you get to 1. After 0,9, you don't get to 10, you get to 1. And then from there, you continue like that. The next one will be 1,1, 1,2, 1,3, and so on and so on and so on. So please make sure that you go and check your rulers and make sure that you know how to interpret. But this does not only apply with your ruler, okay? It's like if you are given a grid, if maybe you are given a grid and then you have to come up with a scale. So please make sure this is how you divide. You check what is this number there, what is the number there, then you calculate the difference. 1 minus 0, and then you divide by the number of intervals. You count the number of intervals there. Okay, so this one we've got 1 centimeter, and then the blue line represents 0,5, and then it's 10 lines per centimeter, so it means each one is 0,1. So boys and girls, please make sure that you go and check your rulers and make sure that you do have those values. Okay, then we've got again bathroom scale. Okay, you must also be able to interpret it. If you look at this one, the hand of the bathroom scale is somewhere between 60 and 70. But how do you interpret? If you look at 60 and 70, so where is it there? Between 60 and 70, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 70 minus 60, you get 10. Then you divide by 10. So it means each one represents 1. So this will be 61, 62, 63, 64, 65, 66, 67, 60. 8, 69, 70. So you must just calculate the difference and then divide by the number of spaces there. That will give you what each line represents. Okay, it's almost the same as the previous one. How to read instrument of measuring. Okay, some of you at your houses, you do have kettles, and then you see there when you pour in water, then you can actually tell how many liters are there or how many milliliters. So again, it's very important that you must be able to read this. So like this one, it's a jug, and then the measurements are indicated there. So you must also be able to interpret. Like this one, we've got 100, from 100 to 200. We've got 1, 2, 3, 4, 5. Okay, so we've got one. Actually, we've got from 100. We've got 1, 2, 3, 4, 5. Then you divide by 5. So it's almost the same thing there. So it's very, very important that again you can be able to interpret the scale that is given. Right, and then again, how to read instrument of measuring temperatures. Again, we know that the instrument that we use to measure temperature is thermometer. So again, if you look at this one, I've got different thermometers. The first one, the second one, and the third one, you can see that they are not on the same level. If you look at this one, it's about 80. Now I have to read this. This one is somewhere between 80 and 100. But how do I read it? If you look at that one, the smaller lines, again, we say 100 minus 80 is going to give us 20. Okay, or if I want to come up with a scale, if I want to know what each small line represents there, then what I'm going to do, I just calculate the difference. 80 minus 60 is going to give me 20. Then I divide, or I count the number of spaces there. Okay, so in this case, if I count, I get 1, 2, 3, 4, 5, I get 10. So if it's 20 divided by 10, then it's going to give me 2. So it means each one is going to be from this one is going to be 62, 64, 66, and so on and so on. So boys and girls, again, this is all about interpretation of the scale. You must be able to read the temperature there. You must also be able to read the temperature there. As you can see that all of them are on different levels. Okay. Then the other thing, boys and girls, is how to read instrument of measuring time. This one must be measuring time. So like a clock, this you cannot afford to lose marks, boys and girls. This is something that you use on daily basis. Okay, you must be able to read what is indicated there. Remember, in this case, we've got 3 hands in the clock. Okay, this one, the short one, indicate hours. Okay, and this one indicate minutes, and then you've got the other one that always runs very quick. Okay, so that one, it represents seconds. So we need to check. So if this one is given, if you look at this one, what time is indicated there? What time is indicated there? So you can see this one, it means it's 12. And then if you count, you will see that it's 1, 2, 3, 4, 5, 6, 7, 8. It's about 8. So it's 8 minutes past 12. Okay, 8 minutes past 12. It's very unlikely that the examiner will also ask you the seconds. So this one, we must also be able to. So this one, if we write the time, we'll say 8 is 12:08. The format is very, very important. You can't write it like this. Okay, so this one is wrong. So this one we say 12:08. Okay, but sometimes the examiner might say the time that is indicated there, it's actually in the evening. Okay, so it's in the evening or it's in the morning. If it's in the evening, then, or it's in the afternoon, so obviously you have to indicate. So this one will be maybe PM if it's in the afternoon, just after midday. Okay, then if it's just after midnight, then it's going to be AM. So when we come to time, it means you must be able to write time in weights. If the time is given like this one, 23:46, okay, write the time in weights. So this one, it means you must indicate it's 14 minutes before 12. Okay, 14 minutes before 12 in the evening or just before midnight. You need to explain that. Right. And then Write time in 24-hour format. 24-hour format, it means that is where you have to indicate 23. Like this one, they say it's in the afternoon, so it's 12:08. But if it was in the morning, it was going to be 0:08. So this means will be in the morning, but that this one is 24. So this will be 24-hour format. Already, if it's indicated like this, it means already it's in the morning. You don't even have to indicate that it's AM. Okay. But this one, you'll have to indicate whether it's AM or PM. If you don't want to indicate, okay, this one it's already after midnight, so it's 00:08. Okay, so you don't have to indicate AM. Right, and then again, we've got write time in 12-hour format. So the 12-hour format, it's where you're going to indicate AM or PM. Right, then the relationship between speed, distance, and time, boys and girls, it's also very, very important. It's very important that you must be able to change the formula, because the examiner might ask you to calculate speed, but the examiner gives you the formula in this format. Distance is equal to speed multiplied by time. Multiplied by time, so it means you must be able to rearrange the formula. Then this one, I'm sure that most of you have learned this in your classroom, and it's very, very important. You must also check what type of a formula the examiner is giving you. If the examiner is asking you to calculate speed, then you must check if the correct formula is given. If you see that this is not the correct formula for calculating speed, then you need to change it. This one will always say speed is equals to distance over time, or we can say time is equals to distance over speed, and then distance is equals to speed multiplied by time. So you must always check that, because the examiner can be tricky sometimes, as indicated. So this one, you just need to memorize it, because the examiner won't give it to you. Right, and then the other section that is very important, boys and girls, BMI and weight status. Remember, BMI and weight status, they go together. Okay, it's very unlikely that the examiner would ask you to calculate BMI and doesn't ask you to determine the weight status. So just remember the formula. Okay, it's the mass must be in kilograms and the height must be in meters. If the examiner gives you let's say the mass in grams, you need to convert it, or the height in centimeters, you need to convert it, because if you look at the formula there, it says the mass in kilograms and then the height in meters. And then after calculating the BMI, you'll go and look at the table, BMI interpretation. If you calculate the BMI and you find that the answer is less than 18,5, smaller than 18,5, and then it means that person will be underweight. If the BMI is between 18.5, it's from 18.5, okay, until 24.9, it means that person will be normal. Then 25 to 29.9, overweight, and then 30 to 34.9, it's obese, and then extremely obese is more than 35. Okay. Okay, of course, the table that you will get in the exam might be slightly different from this one, but what is important here is, in order to interpret the table there, you must first be able to calculate the BMI and make sure that you are using the correct units there. Okay, so also go and practice BMI and weight status. Okay, then this one, the growth chart, BMI, weight status, and the growth chart also go together. Boys and girls, it's also very important that you know how to interpret the growth charts. So the growth chart, this is the growth chart, so also be able to interpret it. So I just want to indicate something on this one, because remember, in the previous notes, I've indicated the interpretation of the units there, the intervals. Again, is the same thing. If you want to know what each line represents, it means you calculate the difference. In this case, it's 100 minus 95, and then you get 5. And then you divide by the number of spaces there. That will tell you what each line represents. So that is how you should be able to interpret it. Okay, then boys and girls, again, under measurement, perimeter of a square. Okay, this one, you know a perimeter. If they ask you to calculate a perimeter, you are given a square. In this case, it's just a matter of adding the four sides. Remember, in the form of a square, they don't have to indicate all the sides because we know that if it's a square, all the sides are equal. If this one is 4, automatically that one is 4, this one is 4, this one is 4. Then what do? You just add. 4 plus 4 plus 4 plus 4, you get 16. Or some people will just say 4 multiplied by 4. Okay, so you must remember that if you are given a shape of a square and then they ask you to calculate perimeter, and then you just add the four sides. The next one is circumference of a circle. Very, very important. The formula is circumference is equal to 2 pi r, or the circumference is equal to pi d. Okay, if the first one is given, it means you're going to substitute radius. If the second one is given, you're going to substitute the diameter. So we all know that the value of pi is always 3,142. So it means what you need to do in this case, if the examiner asks you to calculate the circumference, then the only thing that you need to do is to substitute the radius. Okay? If a diameter is given, if you are given a diameter, then you know what you need to do. You need to divide the diameter by 2 and then substitute it. Okay? That is for the first formula. But if a radius is given, you don't even divide it. You don't divide it. Radius, you just substitute it. Then we've got the next one. It's circumference is equals to pi diameter. So again, the value of pi is 3,142, and the diameter, you just substitute it as is. But what if you are given only a radius and then you are given this formula? So the examiner gives you a radius, but they say you may use this formula. So it means in order to substitute, in this case, you cannot substitute the radius. You'll have to substitute the diameter. So what are you going to do? You take the radius, you multiply by 2. Diameter, you multiply it by, you take the radius, you multiply by 2 to get the diameter. So in simple terms, we say diameter is 2 times radius, and radius is diameter divided by 2. Okay, perimeter of a rectangle. We have spoken about the perimeter. It's just a matter of adding the four sides. So in this case, you see that with the rectangle, if this side is 6 feet, and then this one will also be 6 feet. If that one is 14 feet, this one will also be 14 feet. So then you just add the four sides. In some cases, the examiner might give you a formula. The formula for perimeter of a rectangle, so this must be a rectangle. Perimeter of a rectangle, in most cases, the formula is 2 length plus 2 breadth. Okay, so that is, if the examiner would be nice to you and then gives you the formula, is 2 length plus 2 breadth. And then guys, please, you do not change the format of the formula. If it's a plus, it must be a plus. Because I know that with this one, most of you are confusing this with length times breadth. This is totally different. You might think that the examiner made a mistake there. The examiner would not make any mistake. So in that case, we expect you to use what the examiner has given you. So if it's 2 length plus 2 breadth, then you just do the substitution. So in this case, if it is perimeter equals to 2 length plus 2 breadth, then we do the substitution. Is 2, our length is 14, and then the breadth is 6. Then we get perimeter is equals to 28 plus 12. Then in the end, you get 40 feet. The other thing that is important, boys and girls, is when you calculate perimeter, make sure that the units are the same. If one side is feet, the other side must also be feet. If one side is meters, the other side must also be meters. Okay, if the examiner specifies the unit, let's say the examiner will say the perimeter must be in meters, and just make sure that all the sides are in meters. If the examiner would say the perimeter must be in kilometers, just make sure that all the sides are in kilometers. Okay, and then again, we've got perimeter of a triangle. They can also ask you to calculate perimeter of a triangle. Now, perimeter of any shape, guys, which is just a matter of adding the sides that are given. In this case, we've got 3 sides. So we just add the 3 sides. But we need to check again. Are all the 3 sides in the same unit? Yes, if you look at this one, each one is in centimeters. So we just say 5 centimeters plus 3 centimeters plus 4 centimeters, and then this one we get 12 centimeters. Okay, some of you would not prefer to indicate the units, they will just indicate the units when they write down the answer. That will also be correct. Area of a square, boys and girls, area of a square, you must know how to calculate area of a square. Don't worry about the formula. The formula will be given. You don't need to memorize the formula. You don't need to memorize the formula of calculating area of a square. What you need to do is just to substitute. Area of a square is side squared. That means we take one side, we square it, we make it to the power of 2. That means you take your calculator, for instance, in this case is 8 centimeters. Then you're going to say 8 squared, or 8 to the power of 2. And this will give you 64 centimeter squared. Okay, so when we come to the formula, we don't actually memorize them, the examiner will. But some of them are very, very easy to remember them. Okay, area of a circle, again, we know that area of a circle is pi times radius squared, or area is equal to pi r squared, one and the same thing. So what you need to do there is just a matter of substitution. If the radius is given, if for instance, in this case, if the radius is 3 meters, then you just do the substitution. Then you say area equals to, in most cases, the pi is 3,142. You say 3,142, open bracket, then is 3, then is square, then we get the answer. So this one, you can just calculate it. Boys and girls, you can see if you're getting the correct answer. You're getting the same answer between yourself. Right, and then area of a rectangle. Area of a rectangle, it's area equals to length times width. I know that some of you would use length times breadth, but this is one and the same thing. Length times breadth. Remember, when we come to a rectangle, if you think about any rectangular shape, we actually take the longer side and multiply by the shorter side. We take the longer side, we multiply by the shorter side. Because if you think about area of the floor of your classroom, if you take, let's say, for instance, you want to calculate the area of the floor in the classroom, then obviously we're going to take the length, we multiply by breadth. We take the longer side of the classroom, we multiply by the shorter side of the classroom. And then if you have to calculate, let's say, for instance, area of a classroom wall, then obviously in that case, the longer side will be the length, and then the shorter side will be the height. But what matters in that case is we're taking the longer side, we're multiplying by the shorter side. Okay, area of a triangle, again, you don't need to memorize it. What you need to know is just you must be able to substitute. So this one is area equals to half times base times height. Now base, we are referring to the bottom side of the triangle. And then the height, we are referring to the perpendicular height. Okay, so the height, it must be from the lowest point to the highest point. So it can also be on the side, from the lowest point to the highest point. So what you need to know is you need to know how to substitute there. Okay, so that is area of a triangle. Then we've got total surface area of a cube. Okay, then you know that when we come to the total surface area, what are we referring to? We are referring to the area, the total area of all the faces. Now, how many faces does the cube have? It has got 6 faces. And in this case, each face is a square. So it means you can just calculate the area of one face and then you multiply by 6. So like this one, it's 5, that one is 5. So the area of this face is 5 squared. Then this will give us 25. Then how many faces do you have? Then you say total surface area is equals to 25 multiplied by 6. Then you get the answer. In some cases, they'll give you the formula. If they give you the formula, you do the substitution and get the answer. Right, and then we've got total surface area of a rectangular prism. Boys and girls, again, you don't need to memorize. What you need to know is substitution. Just make sure that you substitute the correct value at the correct place. There we've got 2 in bracket, we've got length times width plus width times height plus, length times width, and then it's plus width times height plus length times height. So make sure that you do the correct substitution. The other thing that is important in this case, make sure that all of them, the length, the width, and the height are in the same unit. If the examiner will say, calculate the total surface area in meter squared or in square meter, then you have to make sure that the length, the width, and the height, all of them are in meters. Okay, if they say in square centimeters, in centimeter squared, you make sure that the length, the width, and the height, all of them are in centimeters, because you know how to do the conversion now. Total surface area of a cylinder, again, boys and girls, you don't need to memorize it. Okay, you don't need to memorize it. 2 pi r squared plus 2 pi r h. Okay, in some cases they use a slightly different, but in the end it will give you the same answer. So the examiner might still give you 2 pi r and says r plus 2h. Okay, so don't be surprised if the formula is slightly different. But what is important here is for you to be able to substitute and simplify. So whether this one is given or the other one is given does not matter. In the end, you still get the same answer. But what is important here is if the examiner says in meter squared, then you'll have to make sure that the value of the radius is in meters. The value of the height is in meters. And this radius and that radius are the same. Okay, they are in the same form. So if the radius is 2 there, if the value of the radius is 2, the value of the other radius is also 2. It can't be something different. Right, total surface area of a triangular prism. Now, if you think about this triangular prism, how many faces does it have? Okay, how many faces does this triangular prism have? If I look at this one, I've got this triangle in front and the other triangle at the back. So I've got this triangle, I've got the other triangle. Then I've got this rectangle, one, and then the other one on the other side, and the other one at the bottom. So if you look at this, I actually have 5 faces. So what I've indicated here is the area of each and every face. So if you look at this one is the front face, which is a triangle. The formula for calculating area of a triangle, it's half base times height. So it's base times height, and then I get 6. The area of the face at the back is the same. It's the same as the one in front. So that is why we have indicated 6 there. And then at the bottom, it's a rectangle. The longer side multiplied by the shorter side. So it means this length and the base of the triangle is also the base, the breadth of the length of the bottom face. The length of the bottom face, there it is. And then this one we say is the breadth of the bottom face. But that breadth is the same as the base. Then we've got back 6. And then we've got, the bottom one is 3 times 9. It's 9 times 3, we get 27. The one on the left is this one on the left. So the two sides, it's still 9, and then we multiply by 4. Okay, 9 multiplied by 4, we get 36. The one on the right-hand side is this one. Okay, so it's 9 multiplied by 5, or 5 multiplied by 9, we get 45. Then in the end, we get the total surface area, which is 120 square centimeters. Now, this one, I'm just trying to indicate that actually when we come to the total surface area, we are actually referring to the total area of all the face. If you calculate the area of each and every face, and then after that, you add them together. All right, and then the next one, volume. Boys and girls, you must also know how to calculate the volume. This one is volume of a cube. The formula is not given there. The formula for calculating volume of a cube is side cubed. So it means if one side is given, remember in a cube, it means all the sides are equal. So this one, each side is 6 centimeters. So when you do the substitution, it's 6 to the power of 3. Then if you do this on your calculator, 6 to the power of 3, 6 to the power of 3, and then you get 216. Okay, so it's 216. And remember the unit of volume. If you have to calculate volume of any shape. If sides are given in centimeters, it means the unit will be centimeter cubed. If the sides are given in meters, and then the volume will be in meter cubed. If they are given in millimeters, the volume will be in millimeter cubed. But if the examiner specifies and say, okay, I want the volume to be in millimeter cubed. But if you look at this one, the sides are given in centimeters. So what are you going to do? It means you'll have to convert. You'll have to convert these dimensions. Convert them to millimeters so that when you substitute there, the answer that you get will be in millimeter cubed. The same thing with volume of a cylinder. Boys and girls, the formula for calculating volume of a cylinder is V equals to pi r squared h. But remember, in this case, it means we've got 1, we've got 2, we've got 3 unknowns. We've got volume, we've got radius, we've got height. If the examiner has to ask you to calculate volume, it means somehow radius and height are given. Okay, the radius and the height would be given. So you just have to substitute. But the examiner can also ask you to calculate the height. The examiner can give you the volume, can give you the radius, and ask you to calculate the height. So how are you going to calculate it? If you think about that formula that we used, the one about speed, okay, you can also use it to practice this. So we say V equals to, right, it must be triangle. Well, okay, so it's V, then it's pi r squared h, pi r squared h. So this one I've got 3 columns there. So V is equals to pi r squared h. I know that if I have to calculate volume, I'm going to multiply this, and that one. Is the formula the way it's given. But what if they ask you to calculate height? Then you're going to say height is equals to V, which is at the top, and then pi r squared. Pi r squared. Then you just do the substitution. That is how you change it. That is how easy you can change it, right? But they can also ask you to calculate the radius. If they ask you to calculate radius, what do? You say r squared equals to V is still at the top, then we've got pi h. We've got pi h, and then you do the substitution. But now, here's a problem. After doing the substitution and simplifying, you're going to have r squared there. Then how do you remove the square? Remember, how you remove the square is you put your answer under the square root sign. So if, let's say, on the right-hand side, you get r squared is equals to 16. Then you just say r equals to square root of 16. Then that will give you 4. Whatever number would be on the right-hand side, you put it under the square root sign. So these are some of the things that you need to go and practice them as well, boys and girls. Right, and then volume of a triangular prism. Okay, so this one, what is important is you must be able to do the substitution and then simplify. So the formula, remember again, the formula will be given. Volume of a triangular prism, this must be a rectangular prism. Okay, volume of a rectangular prism, it's length times width times height, or length times breadth times height. Then the other thing that is important, just make sure that the units are the same. If the examiner says in meter cubed, then the length, the width, and the height must be in meters. In centimeter cubed, then everything must be in centimeters. Okay, then when we come to maps and plans, again, boys and girls, remember the number scale. Okay, number scale, it's given in numerical form. There is the number scale. Okay, so this number scale, what does it mean? It means the picture that you see there, it's actually 500 times smaller than what it is in reality. Okay, it is 500 times. Remember, it has been reduced. Okay, so it's 500 times smaller than what it is in reality. But the examiner might also ask you to explain. That is how you explain it. Or you can say 1 unit on the map represents 500 units in reality. 1 unit on the map represents 500 units in reality or on the ground. Or you can say 1 centimeter on the map represent 500 centimeters in reality. Make sure that the units are the same. You can't say 1 centimeter and the other one you say millimeters. Or you can also use millimeters or centimeters. But remember, you can't use meters or kilometers. Okay, so there's the number scale. You should know about the number scale. And how does it work? Okay, for the number scale, if let's say for instance in this case you have to measure the length of the school hall if you want the real, and then when we measure this one, let's say we get 3 centimeters, it means the 3 centimeters must be enlarged. We multiply by 500. 3 centimeters multiplied by 500. So from that 3 centimeters multiplied by 500, and then you calculate it. Okay, so this one I'm just reminding you about the number scale. Okay, but they can also ask you about the advantages and disadvantages of a number scale. All right, remember, if now I have to enlarge this, okay, let's say I need to make a copy, okay, and then I make a copy, but I want to make it two times bigger than it was. Okay, so what's going to happen? So it means this now will no longer be applicable. It will not mean if I multiply by 2, but this will still be there. So it will mean it is still 500 times smaller than what it is in reality. That will be no. So there's a disadvantage here, because if you change the size of, then the scale will no longer be applicable, or the scale will no longer be correct. And then we've got bar scale. Again, there's the bar scale. And then again, boys and girls, if you know how to use a ruler, you should be able to measure the length of the bar scale as well. If this one, if you have to measure it, so I would advise you to please measure it from this point to the end point. Okay, you see this one, it means 20 meters. So it's 20 meters. So if you measure it using a ruler, it will give you how much is there. So maybe it might be like, for instance, 2 centimeters means it's 20 meters when you measure it. 20 centimeters on the plan, it's equivalent to 20 meters in reality. But you must be able to measure the bar scale as well, boys and girls. So again, I'm just reminding you that paper 2 has got bar scale as well. So you must also go and practice that. Right, then compass direction, boys and girls. When we come to compass direction, this is the easiest of them all. Again, you cannot afford to lose a mark when they ask you for a general direction or for a compass direction. So, and then again, with this compass, the examiner will always give you the direction of north, where north is pointing. Okay, so if north is pointing in that direction, it means you must be able to complete the compass. Okay, so from this one, you know that if you want to complete it, okay, I've seen even some of my colleagues have used some of the ways so that you can remember it. So it's never ever smoke weed. Okay, and then you know that between north and east is northeast, and then we've got between south and east is southeast, and so on and so on. But remember, it's all about where the north is pointing. If it's pointing in this direction, then you must also be able to complete it. If it's pointing in this direction, north, you must also be able to complete it, and so on and so on. So the north direction will always be given. What you have to do is just to go complete it, right? And then again, just remember that the sun rises in the east and then sets in the west. So that is what is important as well. Right, and then when we come to maps and plans, again, boys and girls, you might get a question that is based on a sitting plan or layout. Now, a sitting plan can be for a classroom, it can be for a cinema, it can be for a church, it can be for an auditorium, and so on and so on. So there will be questions based on a sitting plan. So you might get a question that is based on a sitting plan where they're going to indicate the number scale or the bar scale, and also the directions, how many windows, and so on and so on. So sitting plan, it's one of the maps that you must also expect. You might also get a map of sports field. Think about the sports field. This one, it's a map of Hamilton Boys High School. Okay, it indicates all the fields, everything in the school. There we've got rugby two, so that means they've got about 5 rugby fields. Okay, and then they've got about 2 football fields, actually 3. Okay, so it is all about, and then it also indicate where the aftercare and then Saturday car park is, and so on and so on. So you might also get a map of a sports field or any other map. It can be a map of a zoo and so on and so on. Right, a map of a shopping center again. So a map of a shopping center might also be given where they might ask you a question about giving a direction from one shop to another shop and so on and so on. Right, map of a sports stadium. Okay, a map of a sports stadium might also be given, and then they ask you questions based on that map. And then street map with grid or without grid. So this one I think is very important. If they are going to give you a map with a grid, obviously they might ask you for a grid reference. Grid reference, for instance, if you look at this one, if it's not clear, it shows A, B, C, D. Then we've got 1, we've got 2, we've got 3, we've got 4. Then they might ask you, in which grid reference do you find university? So if it's in this grid reference, and then that will be B3. Okay, so they can ask any other place that is indicated in which grid reference. So when we say, if they're going to give you a grid or a street map with grid, definitely they're going to ask for a grid reference. So a grid reference, they're just checking that if you know where the place is. So if you have to look for this place, it means you're going to look in B3. Right. Then the next one, provincial or national map. Now we know that when we come to provincial or national map, they might ask you about a direction. They might ask you about the national road. Okay, they might ask you to mention the national roads that must be followed when you move from maybe, let's say, Polokwane to Cape Town, and so on and so on. So you must know all the national roads as well. You must be able to give a direction. So provincial and national. But when you come to the provincial, remember we've got regional roads, the R80, okay, the R81, R82, and so on. Those are the regional. So you also need, you should also expect something like this as well. And then a street chart map, okay? So a street chart map, remember, a street chart map, boys and girls, it's actually not, if you look at the routes, most of them are straight, but we know that in reality, the routes are actually not straight. So this one is just a picture, just to give you a picture, just to give you an idea of how to move from one place to another. So this is a street chart map, but never mind the straight lines, even though we know that in reality they're not straight. That is the whole idea, just to give you a rough sketch of a map. Okay, elevation map, okay. You know, sometimes when you travel on a road, the road has got ups and downs and so on. That is the elevation map. So if you look at this one, it has got ups and downs and so on and so on. So that is the elevation maps. So that one, we're going to look at the altitude. Maybe if you're traveling from Pretoria to Johannesburg, you can see that, okay, you're actually going down, or from Johannesburg to Pretoria. So that is all about the elevations. Okay, then remember the instruction and assembling directions. So this one, I gave an example. Let's say if you go and buy an office chair, okay, or an armchair and so on, remember it comes in a box. So, but when it comes in a box, there's always an instruction that must be followed for you to assemble. So you must also expect some questions where they're going to give you, or they're going to indicate the steps, and then you have to give the instruction on how to assemble and so on. So instructions and assembling directions, you must also go and practice that, boys and girls. Right, and then we've got again packaging. Okay, so when we come to packaging, obviously, if you have to pack the cans, if you have to pack cans in a box, how many of them are going to fit lengthwise, and how many of them are going to fit breadthwise? Like in this case, the number of cans that will fit in the box, okay, that will be determined by the diameter. Okay, so for this one, it means you are going to take the length of the box, you divide it by the diameter of a can, just one can, and then that will tell you how many are going to fit lengthwise. And then on the other side, you take the breadth, you divide it by the diameter. You don't divide it by the radius, but you divide it by the diameter. So obviously, if the examiner would give you a radius, you would have to multiply the radius by 2 to get the diameter. So like this one, if you take the length and multiply by the diameter, you can see you're going to have 1, 2, 3, 4, 5, 6 of them that are going to fit lengthwise. And then breadthwise is going to be 1, 2, 3, 4. But if they ask you the total number of cans that are going to fit, you can't say 6 plus 4. Okay, remember it must be 6 times 4. You multiply, you don't add. It's not 6 plus 4, but it's going to be 6 times 4. Like in this case, you can see that is 6 times 4, therefore it's 24. So you must also go and practice this type of questions. Obviously, if it was a different shape, let's say if it was a rectangle or a rectangular prism, then it means it was going to be a different thing. You're going to divide by either the length or by the breadth. So you must also go and look at this one. Okay, the floor plan and elevations. Please expect some questions about the floor plan and elevations, and then you must know if a compass is given. If let's say they indicate that this is north, you must know which one is the north elevation, which one is the west elevation. So this one, I've just indicated the picture there just to give you an idea. And there we've got the floor plan. Okay, now boys and girls, just a few questions about the basics. Okay, so when we come to the basics, we have spoken about conversions. You must be able to convert metric system. So now, for example, we've got question 1. Sarah wants a ceiling in a house. Her son measures the length of some of the walls as follows. Okay, measured 3,752 millimeters. The other one is 354.5 centimeters. The next one is 4.1 meters. Convert all the measurements to millimeters, centimeters, and meters. So it means each one of these must be converted to millimeters at number A. So if we've got 3,752 millimeters. Now you need to think, how do you convert from millimeters? How do you convert from millimeters to millimeters? This one is already in millimeters, boys and girls. This one is already in millimeters, so you can't convert it. So you just rewrite it as is. Then the next one is 354.5 centimeters. 354.5 centimeters. Now the question is, how do you convert from centimeter to millimeters? This is something that you should know. Converting from centimeters to millimeters, you have to multiply by 10. Usually I tell learners that if you look at most of the rulers, the two edges, one edge is in millimeters, the other edge is in centimeters. So if on the other side you've got 1 centimeter, the other side you're going to have 10 millimeters. So it means basically from a centimeter to a millimeter, we multiply by 10. So this one, you just multiply by 10. So 354.5 multiplied by 10, then this will give us 35.45. And it's now millimeters. Okay, so that is how you convert. Then the next one is 4.1 meters. Now 4.1 meters, how do we convert from meters to millimeters? Okay, go to your method, whether you're using the King Henry or any other method, but this is something that you should know. How do we convert from meters to millimeters? That is, we multiply by 1,000. So if we multiply by 1,000, if you take 4.1, you multiply by 1,000, and then we get 4,100. 4,100 millimeters. So 4.1 multiplied by 1,000, we get 4,100 millimeters. Okay, then if you take the very same values, now we want to convert them to centimeters. We want to convert 3,752 752 centimeters. How do we convert it? How do we convert it to centimeters? How do you convert the 3000, sorry, it's millimeters. Okay, 3752 millimeters. We convert it to centimeters. How do you convert from millimeters to centimeters? Boys and girls, you should know the conversion factor between millimeter and a centimeter is 10. Are we going to multiply or are we going to divide? So in this case, from millimeter to centimeters, we divide. So if we divide, we get 375.2 centimeters. Okay, so from millimeters to centimeters, we divide. Boys and girls, it's very important that you go and revise all these basics. You cannot afford to lose marks when you come to these easiest questions. Right, then the next one, we've got 354.5 centimeters. We need to convert it to centimeters, but we can see that it's already in centimeters. 4.1 meters, if we want to convert it to centimeters. Now, if it's 4.1 meters, we convert it to centimeters. How do we convert from meters to centimeters, boys and girls? We multiply by 100. The conversion factor is 100. So we take 4.1, we multiply by 100. So 4.1 multiplied by 100, and this will give us 410. Okay, 410 centimeters. So it's 4.1 multiplied by 100, and then you get 410. Okay, then the other conversion is if we take the very same values, now we convert them to meters. There we take the very same millimeters, 3,752 millimeters, we convert it to meters. Come on, boys and girls, you can do it. How do we convert from millimeters to meters? We know that we need to divide by 1,000. Okay, we need to divide it by 1,000. Now, if you take 3,572, 3,752, then you divide it by 1,000. Then this will give you 3,752. Okay, so it's 3,752. You divide it by 1,000. Okay, it's 3,752. So 3,752 meters. Then 354.5 centimeters. How do you convert it to meters? How do you convert from centimeters to meters? Okay, so obviously you have to divide by 100. If you take 354.5, you divide it by 100, then that will give you 3,545. So this one, if you use a calculator, 354.5 divided by 100, then that will give you 3.545. Okay, right, and then the next one is we need to convert. A juice has a capacity of 6,500 liters. A juice that has a capacity of 6,500 liters. How many 500 milliliter bottles can be filled from the vat? Okay, so we take 6,500 liters. We have to divide it by 500 milliliters. Okay, now, but you need to be careful, boys and girls. We need to be careful because you can see that both of them are not in the same unit. For you to divide, both of them must be in the same unit. So what do we do in this case? We need to convert one of the two. We can convert milliliters, we convert it to liters. Now, how do we convert from milliliters to liters? We know the conversion factor. The conversion factor is 1 liter. It's equals to 1,000 milliliters. Okay, 1 liter is equals to 1,000 milliliters. So if we want to convert from milliliters to liters, or if we want to convert from liters to milliliters, we multiply by 1,000. But if you want to convert from milliliters to liters, we divide by 1,000. So we take 500, we divide it by 1,000. So this will give us 6,500 500 liters divided by, if you take 500, you divide it by 1000, that will give you 0.5. It's half of a liter. So 6,500 divided by 0.5, and then it's 13,000. So it's 13,000 what? Bottles. So it's 13,000 bottles. So that is how you calculate. So the main thing behind this is conversion. So we have to convert the capacity of the bottle. So we take 500 milliliters, we first convert it to liters. Okay, this one is again converting mass. A brick has a mass of 4,550 grams. Convert the mass of the brick to kilograms. Question, how do you convert from grams to kilograms? What is the conversion factor? We all know that 1 kilogram is equals to 1,000 grams. So this one, it means if we want to convert from kilograms to grams, we multiply by 1,000. But if we want to convert from grams to kilograms, we divide by 1,000. So we've got 4,550. We need to convert it to kilograms, so we are dividing 4,550. We divide it by 1,000, and then this will give us, I think, 4.55 kilograms. Okay, 4.55 kilograms. Then we've got again, how many bricks can be carried in a truck designed to carry a maximum load of 9.1 tons? Okay, can only carry up to 9.1 tons. Okay, so how many of these bricks can be carried by the truck? We need to check if the truck is 9.1 tons, then there we are given that 1 ton is equal to 1,000 kilograms. Okay, so for every 1 ton can, 1 ton can carry up to 1,000 kilograms. So if it's 9.1, then we take 9.1, we multiply by 1,000, then this will give us 9,100. Okay, 9,100 kilograms. Then now we divide by the mass of 1 brick. So we take 9,100, we divide it by 4.5. Okay, what is important here is we need to divide. We could have said 9.1 ton divided by 4.55. But now the problem is we need to convert the ton. So that is why I change ton to kilograms so that I can divide by the same unit. So 9,100 9,100 divided by 4.5, so that will be about 2022. Okay, so 2022 bricks. Okay, so it's 2022 bricks. Okay, now boys and girls, I was just trying to give you the basic calculations. So it means it's now up to you to go and make sure that you practice all this. What I was doing here, I was actually just refreshing your memory in terms of what you have covered throughout the year. Okay, so in terms of refreshing your memory, I have covered that one. So unfortunately, we would not be able to do all the activities because time is not on our side. But what you need to know is you need to go back to all the topics, check all the topics. If we say we're going to write about measurement, what must be covered? What must you practice under measurement? Okay, and then if we do maps and plans, what do you need to know under maps and plans? So it's very important that you must go and practice all those, or you must go and practice all the exercises that are based on those topics. So it's very, very important. So like I said at the beginning, likely for paper 2, you've got today, you've got tomorrow, you've got Sunday. So I'm quite sure that you're going to do better than paper 1. You're going to do much better than you did in paper 1 because now you're going to have more time to study. So I wish you all the best on Monday and make sure that you study. Thank you.